Um, Hello guys, my name is Zhong Cheng Hao. Greeting from me to all of you, especially to all my friends in mathematics class A1 and also my lecturer Juan Olia, who teaches me geometry for PISMP semester 2. So today, in this video, I'm going to show you two things. There are two things. One is the product. There are two products actually. Number one is the solid that I built, and another one is the pop-up manual book. Uh, So we have two things. At first, I'm going to explain the details and the process of making my solid. I produce a platonic solid. Um, there are many platonic solids, and one of them is icosahedron. So uh, I've decided to produce an icosahedron, and we start with the first picture here over here. So uh, this is the first step, which is drawing. To produce a solid, uh, we need to find suitable materials, such as papers or anything. But prior to this assignment, because this assignment requires us to show our ability in paper engineering, so we must use paper to produce this solid. So here comes to step number one, which is drawing using pencil. We use a piece of paper, and the task requires us to use recyclable items. Yeah, to in order to save the environment. I think like, in my opinion, using recyclable items to produce this kind of product are very meaningful because it can save our environment. So, uh, all right, the first step is quite easy. After we draw, uh, we make some scaling also because we need to make sure that every length and the width of the triangle is accurate. Uh, so to produce this solid, because my solid is not that big, it's just the size is 2 inches, which means that every side of the icosahedron, the length is 5 cm, which is 2 inches. After that, after the drawing is done, we add another piece of drawing into each side of the drawing here. As you can see, this is we need to cut out all of this, and especially this part. This part we glue over here. We use a glue to glue it, and then so that we can glue this paper to we can, how to say, because we want to make a solid, so we use a glue to glue it, and then this part, uh, all of the portions over here, they can they can stick together, and then the solid can be formed. So the principle of building the solid for me is like this, quite easy actually. And and then we cut it. Yeah, I cut it, and this is the drawing, the first structure of the icosahedron before it is being folded. Because we use a glue, this glue to glue it over here, over here, over here, over here, and then we um, paste it together, we stick it together to form this kind of solid called icosahedron. And then we also use sellotape so that uh, this icosahedron is more uh, firm. because we need this solid to be more firm, so that uh, it can last longer. It will not easily break. Uh, Now, to produce this kind of product, we can use a lot of things, and one of them is I add some recyclable items such as tissue paper, just some of it, to make it to make this solid more compact, so that it will not easily be I mean outshape, or the it can be easily um, shed because of the force that applies to it. When you press it, it will become it will be like that. It will be, but it will not be completely destroyed. It's just when you apply force to it, when it's just when there's nothing inside this solid, because it consists of papers only. There's nothing inside. If you put something inside, this solid will become very stable. In other words, it is not easily compressed. Because I want my product uh, to be more firm. The quality must be good. So this is the final product. Uh, well, as you can see, this icosahedron consists of it consists of 20 triangles, if I'm not mistaken, 20 faces, and all of them are triangles. There are so many characteristics, and I will describe more about this solid. Mm, I will just describe this solid in the Core Amino book, because I also produce a Core Amino book that describe and focus and really focus about this icosahedron. As you can see, uh, well, before I end this part, I would like to before I will sorry, let's continue. So one more thing I want to say about this icosahedron is um, the properties of this solid, because this is platonic solid, so it is not that complex. As you can see, there are 12, only 12 vertex or vertices. Vertices is plural. In singular, it's vertex. Vertex is the point where all the edges meet. I mean, all these sides meet. Yeah, all these sides meet to form sharp, uh, a sharp. What would say? There's a sharp thing here. This is what we call vertex in singular word. In singular uh, form. Besides that, as I have mentioned before this, there are 20 faces, which are also known as 20 triangles over here. Uh, it consists of 30 edges. 30 edges. And because you can see that there are 5 edges meet at each other at this point, this sharp point, we call vertex, which also means there are 5 triangles meet at each other at here, at this point, vertex. Oh, I forgot to mention that these 20 triangles, they have same length, same width, same height. So they are equilateral. No, yeah, they are equilateral triangles. But they really have, in fact, they have same length. Yeah, they have same length. Three sides. They consist of 3 sides. They have the same length. For example, I produce this 5 cm, 5 cm, 5 cm, because it is 2 inches. So length of the side, every side of this triangle has the same length, which is 5 cm. So we've done with this platonic solid. We move on to the next product, which is the pop-up menu book. This is the cover, the front page of my pop-up menu book. This pop-up menu book mainly describe about the process and the properties of the icosahedron. Same like what I have described before this, what I've explained just now. More than it's just more or less like that. uh, the same pictures that I've shown just now. The properties of icosahedron. This is the polynomial book. And to produce this polynomial book, I also use paper. I use cardboard paper, as you can see. Cardboard paper is maybe it's I mean um, it can be recyclable, which is good for environment. But the best thing about cardboard paper is it is better than normal paper, because uh, it has many properties because it is very colorful. I mean, I use the cardboard paper that consists of many types of color. As you can see, yellow, yellow and red. We have red over here. Very well. Uh, all right, we continue. Oh, why this cardboard paper is more but is better than normal paper is because it's somehow rougher, thicker than normal A4 paper. That's what I want to mention about. All of these products are actually uh, are used. I use recyclable items, recyclable materials to build all of this, to make all of these things. Uh, it's just a simple project for me. Oh, and to produce this polymer book, there are many techniques that I use. Um, so many techniques, folding techniques. There are valley fold, hill fold, and many more. I've used the technique of hill fold. As you can see, there's a part that stretches out here. This is what we call hill fold. It looks like a mountain, so that we can pass anything onto it. We can paste anything on it above it, uh, as you can see from here. So this is how we produce a pop-up structure over here. I just basically paste some pictures that I have printed. These pictures are about the process of making the icosahedron. As I've mentioned before, I produce uh, I use besides folding techniques, I also need to know the basics of how to fold a paper. It so that's how I get myself knowing the basic knowledge of origami. So I need to know how to fold this and use my creativity to produce this pop-up menu book. Pop-up book actually. Pop-up book is really funny, interesting, and it really mm, this pop-up book it really makes me uh, not that um, not that stressful. It helps me to relieve myself so that I don't feel that stressful during my life as a undergraduate because I haven't graduate. So I actually sometimes I also like to create some products like this to boost my creativity, and also I would like to take part in many kind of innovations to produce many kinds of uh, products which are useful for learning and also for fun, for entertainment. So that's why I produce these these two products. I think that's all from me. The explanation for these two products are done. just basically an introduction and so the explanation briefly explain about how I produce these two products and the techniques I use. Yeah, there are a lot of techniques that are required to be used to in making this formula book. However, to produce this icosahedron, the technique not that much, just some simple folding technique. Uh, because this icosahedron is quite easy to be made, in my opinion. So I think that's all from me. Thank you. Thank you.